Hi guys, in this video for today, we are going to start taking some notes on page 12. So it's the lined page right after what we were just working on yesterday. And we're going to start talking about what is the significance of this point for the two rules and also this solution of a system of linear equations. Okay, so over on page 12 at the top, I would like you to write solutions to linear equations. And if you listen to the entry task talk earlier, then you know that a linear equation is just an equation of a line. So if I graph a linear equation, I would have a line, right? And that's in that y equals mx plus b that we've been working on, where b was our y-intercept and m was our growth or our slope. Okay, so now we're going to start talking about solutions to these linear equations. So let's start with checking a solution, and then we'll come back to talk about what a solution actually is. Okay, so first let's talk about checking solutions. Okay, so if I gave you the equation, sorry, I need to scoot over a little bit. If I give you the equation y equals 2x plus 4, and I wanted you to check the solution of 3, 10. All right, so when we have an ordered pair, we think about, what does this 3 represent? Well, 3 represents where our point is on the x-axis, right? And then the second number, the 10, is always the y. Okay, so when I have an ordered pair, it's always x, comma, y. So I'm going to substitute, I'm going to substitute this 3 for the x and this 10 for the y and see if I get a true statement. Okay, so I have 10 equals 2 times 3 plus 4. Okay, so 10 equals 2 times 3 is 6 plus 4 makes 10. So that solution is correct. Okay, the solution of 3, 10 is correct. All right, let's try another one. Y equals 5x minus 2 for the solution 3, 10. Okay, we'll just keep the same solution again. So again, x and y. So I'll put 10 in for my y and 3 in for my x. So I have 10 equals 5 times 3, which is 15, minus 2, which gives me 12. Oh, wow, 13. I know my math. Now, is that a true statement? No, which means that this is not a solution. All right, but what if I wanted to find a solution for that? Okay, so I know that that is not the correct solution, but I'm going to try finding a solution now. So finding solutions. Okay, and let's use this same one that we just had up here. Y equals 5x minus 2. And now I want to find a solution. So let's think about what a solution actually means. Okay, so in this case, our solution is an ordered pair, which means that if I graphed this line, 3, 10 would be a point on that line. Okay, if I graphed this line, 3, 10 would not be a point on that line. So when we're finding a solution, we're just finding a point on a line. And since we use arrows, right, a line is never ending. So even though right here, it looks like X only goes to about here on my graph, if I extended this line forever, eventually I would end up with some really big X numbers. And if I extended it forever in this direction, eventually I would end up with some really negative X's, right? So I have an infinite number of points on this line. If we think about infinite, that means it's never ending. So there is there is an infinite number of points that could fit on this line. So I just need to find one of them. So what we're going to do is just choose a random number for X. Okay, so choose any number for X. Okay, so in this case, let's keep it with, or no, let's change it. Let's do 4. Okay, now I'm going to substitute the number for X in the equation. Okay, so I'm going to put 4 in for X. So Y equals 5 times 4 minus 2. Okay, Y equals 5 times 4 is 20 minus 2 gives me 18. So now I have Y equals 18, which literally means that the Y value is 18. Now, if I were to plug that 18 in for Y over here, I would have 18 equals this, and 18 equals 18. That's a true statement, which means that I have a correct solution. All right, let's try another one. All right, let's do Y equals 2X minus 6. Okay, and I want to find a solution for that. So again, I'm just going to choose any number for X. It doesn't matter what it is. So in this case, I'm going to do 3. Okay, so then I'm going to substitute this 3 in for the X over here. So I have Y equals 2 times 3 minus 6. Y equals 2 times 3 is 6 minus 6 is 0. So that means that that has to be 0. And now if I were to put 0 in for Y, I would have 0 equals 0. So I know that this solution is correct. All right, but what if I wanted to find another solution? Okay, so using the same equation, I want to find a different solution because remember, each line has an infinite number of solutions. Okay, so I am going to choose a random number. In this case, I'm going to try a negative. So let's do -3 and see where we end up. So I'm going to substitute that -3 in for X over here. So I have Y equals 2 times -3 minus 6. So Y, 2 times -3 is -6, minus 6 gives me -12. So that means that when X is -3, Y has to be 12. Okay, so then that means that this is a correct solution for the same equation. So we can have an infinite number of solutions. Any solution, or not any solution, but never ending. Lots of different options. All right, I'm going to flip over to 12A. It's a blank page on the back of this, and let's talk about systems of equations now, or systems of linear equations. Systems of linear equations. All right, so on page 11a, we have these two equations right here. So I'm going to copy these down on this page, one on top of the other. So I have y equals 3x minus 4, and we have y equals negative 2x plus 6. Okay, now this is a system of equations, which is just a fancy name for a group of equations. Okay, so we graphed these two lines on our grid yesterday, and we found that the point of intersection, or the point of intersection was 2. So this point of intersection is actually really important. Okay, so our point of intersection was 2, 2. Now, what does this mean? Well, first, let's just try this as a solution to this first equation. Okay, so let's check to see if that solution even works. Okay, so I have 2, 2, and first I'm going to do y equals 3x minus 4. So I'm going to substitute 2 for x and 2 for y. Okay, so I have 2 equals 3 times 2 minus 4. Okay, 3 times 2 is 6. 6 minus 4 gives me 2. So I have 2 equals 2, which means that 2, 2 is a solution. That's a lot of 2's. All right, now let's do the same thing, but with the other equation. Y equals negative 2x plus 6. Okay, and we're going to substitute 2 for x and 2 for y again. So I have 2 equals negative 2 times 2 plus 6. All right, so negative 2 times positive 2 is negative 4. Negative 4 plus 6 is positive 2. Okay, so that's also a solution for that equation. So this point of intersection is the only solution that works for all equations in the system. And I wrote all equations, not both, because sometimes we'll have a system of equations that has more than 2 equations in it. Okay, so it's the only solution that works for all equations in the system. So let's check that out and see if that works. Okay, see if it's the only solution. So first, let's just find a different solution for y equals 3x minus 4. Okay, we're just going to find a new solution for that. Remember, it has an infinite number of solutions. So I can find another one, no problem. Okay, so first I'm just going to choose a random number for x. In this case, I'm just going to keep it simple and choose 0. Okay, so if I put 0 in place of x, I would get y equals 3 times 0 minus 4. Now, we should all know that 3 times 0 is 0. So I have 0 minus 4, which means y is just equal to negative 4. So 0, negative 4, is a solution to this equation. But let's check and see if that solution also works for the other equation in our system. So I have y equals negative 2x plus 6. And I'm going to substitute 0 for x and negative 4 for y. Okay, so I have negative 4 equals negative 2 times 0 plus 6. So negative 4 equals, again, negative 2 times 0 should be obvious. That's just 0 plus 6. So I have negative 4 equals 6. Okay, I know that that is not a true statement, which means that this solution does not work for that equation. Okay, so this is the only point, the only solution that both lines have. Okay, all of these points on this pink line would be considered a solution to this equation. All the points on the blue line would be considered a solution to this equation. All right, hopefully this is all making sense to you.